All right. So today I am going to discuss the Amazon case study that I gave last week. So the questions that I gave is posted over here. You can click on this and it would open week 3 Amazon SQL interview questions. If you haven't looked into this yet, you can go through this. But these are the questions that I posted earlier. There are different challenges, 6 challenges in total. I am going to discuss all of these in SQL Server Management Studio SSMS. Okay. So the question first is we have to analyze monthly product review trends. You have been expected to work as a data analyst and you are tasked with monitoring product, so on and so forth. Step should you should go through the scenario. We have to write a SQL query to calculate the average rating for each product on a monthly basis. So we need to group by monthly basis and we need to calculate the average. So that is the aggregation. So in the format of output, your final output should present with the month and so on and so forth stuff. So this is the input, review, customer ID, date, item ID, rating, and this is how the output should look like. Okay. So this is what we want to do. So what we will do is we will go quickly to our SQL Server Management Studio and we are going to create a database called as Amazon. We will execute and let's go through that database. Use Amazon. Okay. Okay, perfect. You will see that Amazon is not selected. Now what I want to do is if I just specify the database, if I just refresh the database over here, you will see that Amazon is created. However, there won't be any tables that is created. I am going to create a schema over here. So we should be creating the schema. So that schema is created. All the tables I would be putting over there only. Now, the physical table that we need to create. If we remember what was the question, so this is what we looked after, right? So what I will do is I will copy paste this one, write a SQL query. So this is our first challenge. So I am going to put it over here. Challenge one. Okay. So now we will be first creating the product reviews table, right? So this is the table that we are going to create. To create that, what we will do is we will use this script. This entire script would be available for you to use in the description of this video. You may use it, but I would highly recommend you write one yourself. Right. So let's see what is into this table now. So select star from this. If I just run it now, what we see is it is blank, right? And it should have been blank because we haven't inserted any records here. Now we are going to insert the records into this table. So the records are very much same whatever you see in the image. So that is what I have used here. So I'm going to run this. So I select this. You can press F5 or maybe you can execute it. Now if I just run it again, select star from this. If I do it, you will see that we have got all the records over here, right? So all the records are available. Now what we are going to do is we are going to um, write the query to solve our problem statement. What is the problem statement? We have to write a SQL query to calculate the average rating for each product on a monthly basis. So basically for each product, we need to calculate the rating on a monthly basis and some formatting of this is given. So let's start this by writing it. So select and what we'll do is we have got one table. So I will write this here, select from this table. Right now we will specify what are the columns. So the very first thing is we need to have, if you go into the format, we need to have the review month and then item ID and then average rating over here. So the very first thing is the review month. So select month and then the column of review date, which is review date, as review month. This is the first column. Second column is going to be the item ID. It was item ID over there. And the third column is the average value, right? So we use average over here, and then what we'll do is rating column we are going to use, and then we will just apply the average logic over there. And these things that you see round and other things are used for formatting purpose. I want to keep the decimal till two decimal basically. So average rating over here, I keep it. And I want to insert, I don't want to insert into any temporary tables because this would be straightforward logic from here. But this doesn't end here. We need to group it as well, group by a month of review date, because we have used these columns in our select statement, and then item ID. Okay, so let's see now. Here this should be removed, so I will remove this. Let's run this. So if we see here, review month, item ID, and then average rating. So what it is doing is it is calculating the average value. So that is how we can calculate the average value and group it. Pretty straightforward, just the aggregation and group by, no joins, nothing, just aggregation and group by. That's all. Let's move on to the second question now. All right, the second question. Second and third questions, these questions are more on the conceptual side rather than writing query. So let's discuss these two questions. The second one is how to speed up a slow query on a massive database. You are working as a data analyst in different companies, or you are working as a data analyst over here in Amazon, dealing with a database on immense scale. You run a SQL query essential for your report, but it's taking an unacceptably long time to return results. So we need to, first of all, very first thing is that we need to understand the business first. We need to get in depth of it. We need to check the filters, aggregations, and joins. So start with understanding execution plan. Look for the heavy tables, whether the indexing is good or not. Look for inefficient indexes, how indexing are used. You need to look into the expensive operations like sorting, nested loops, if any, those kind of things you will have to look into. If we are doing any filtering, what we can do is we can apply filter early in the query rather than applying filter after joining, right? So this would be applicable when we are writing complex queries, because if we write early, then it would be relatively it would be quick and efficient. A lot times it might be possible that someone wrote select star, that should be avoided. Include only the columns that are needed, not select star. Joins might not be optimized. Look after what kind of joins are there, what are the tables used, how it is written. So you might like to optimize the joins logic. If you are looking into the where clause, what kind of functions are used. For instance, if you are trying to wrap date functions like year, then that might be taking a lot time because there is a wrapper beyond date column. So that can, if it is possible to avoid that, or what. Now you looked into all of these and still you think that you need to get in depth of it. Then you look on the tables, if you see if those tables can be partitioned or not. So that can be also looked into. Or maybe materialized views can be also created so that it can reduce the recomputation time, and it can also simplify join. So these are the things that you would be doing it up, and including all of these, including an analysis of all of these, you may write SQL query again, or CTE again, or logics again. And these days, I think AI, Chat GPT, GitHub Copilot, and these kind of tools can do it pretty easily, optimize it pretty easily. But it's worth knowing this concept so that you would be able to discuss with your hiring manager. Let's move on to the next one, which is third one. What are the main purpose of constraints? Can you list and describe a few of the most common ones you would use? This question was asked when I was looking for a job long back, and since then I remember this, and this question keeps on coming. So why does this matter? Why constraints matter? So these are the rules basically enforced on data in a table. It is meant to ensure the accuracy, consistency, and integrity of the data. Think it like guardrails, and that these guardrails helps us in preventing bad data to enter into our system. There are a few common SQL constraints. The very first one is the primary key. As you would know, that primary key is used to uniquely identify each record in a table. It can't be null. Typically, it is the ID columns like employee ID or order ID, such kind of things. Then there is foreign key because that creates a relationship between two tables. Then there is unique. It doesn't allow duplicate values, although it would allow one null values. Right? We can have multiple unique constants in a table. Then there is not null, that ensures that a column must always have a value. It can't go without a value, so that if someone is trying to insert null values into that column where it shouldn't be, then you would get an error. Then there is a default constraint. So basically you set some default value. If by the logic, if something is not getting into that column, the default value would be automatically populated, right? So these kind of constraints you should be discussing. Primarily you should focus on explaining the concept why constraint is needed, and then what are the constraints, and you discuss all of this. I think that should be enough. Okay, so let's move on to the next one, which is challenge 4. So in the fourth challenge, the challenge is all about identifying top selling products by category. The scenario is we are working as a data analyst at Amazon. The marketing team is planning its annual top performers campaign and needs your help to identify the highest revenue products. They want to feature two best selling products from each category based on sales data from the year 2022. So that is what they are looking for. We need to write a SQL query to find the top two highest grossing products within each category for the year 2022, right? So this is the logic behind it. Behind this should be the logic behind our query. The output should include the product category over here, item name, which is product name, and the total revenue generated. I'm going to first of all create this table, insert these records, and then would be writing the query. Let's get into our SQL workbench. Not SQL workbench. Let's get into SQL SSMS and discuss it over there. So challenge 2 and 3 discussed the concept, right? So this was about challenge 2 and 3. Now we will be moving towards challenge 4. Okay. So the challenge 4, what is the challenge 4? Let me just copy paste this one so that we can refer back and forth and can write the query. Okay, so this is our challenge. So the very first thing is we need to create the table where we will insert it. So this is the customer transactions table. It has got product category, item name, customer ID, and so on and so forth stuff. So we will be running it. So let's run it. Okay, so I think I used the logic of MySQL Workbench to stay in a query and run it, and that should run this query, but it doesn't work in SSMS. So I selected and executed that one. So what we can do is we can run this one and see that it would be blank. So select star from this table, which is blank. So here, if you see this table, I haven't used any constraints as such. But ideally, when you are designing a schema, designing a system, you would be definitely using the constraints that I just discussed, or that those constraints are there in the system. Since we are just working on this query, so I avoided that to keep it simple, but make sure that you are using the constraints. Now let's try to insert the records. I'm just inserting the records that were over here into our this one, right? So this is what I'm trying to insert. So let's run this, insert into this table. So I execute this. What now we can see is we would be able to see this table, right? what we can see is we can see all of these records are inserted right now over here. Now we are going to create query. We are going to write query to solve the problem statement. Just to repeat, what is the problem statement? The problem statement is write a SQL query to find the top two highest grossing products within each category. So within each category, we need to figure out the top two highest grossing for the year 2022. So this is the filter. You can imagine it like this is the filter where clause or having. We will see where does it go, and within the each category. And this is the format. So what we are going to do is, first of all, we are going to create a table where I'm going to use the temporary table logic. So we will create temporary table with total revenue for 2022 year, right? So select and then from which table? The table that we have got over here, Amazon customer interaction. So this is the table, right? Now what I will do is, let's create here product, include product category and then item name, and then for the revenue we are going to use the total revenue sum of amount spent. So basically sum logic over here as total revenue, right? And then let's put this into a temporary table. We will come to temporary table very soon. So till here we are into this, and then where the where clause here purchase date equal to 2022. So I'm converting purchase date into year using year logic. And then since here I have got selections and aggregations in the select statement, I need to aggregate, I need to group it, right? So I will just replace this one and then just let's run this now. So this year 2022 filter would be coming in where, because we are not using it would be coming in our where clause. So here we have got product category, item name, and total revenue. Let's put this into a temporary table. Into here, what I will do is revenue 2022. So let's put it over here and let's run this. It is the same thing that we would be getting. We can see it select start from this. Okay, so this is the temporary table that we have got. Now what we need to do is we need to rank the products within each category by revenue. Right now there is no ranking, so we need to rank the products within each category by ranking. So that is what we are going to do. So I will write the steps. The very first step that we did is step 1. What I did is here create a temp table with total revenue for 2022. Now we will be moving to step 2. In the case of step 2, we are going to rank products within each category by revenue. So to do this, we are going to use window function like rank. There are various window functions, but here rank would be applicable. So that is what we are going to use. So select star comma rank and then over partition by what? Product category, because that is the column over here, product category. And then order by which column? The total revenue column, because that is where we want to do the order. DESC, right? And I'm going to say rank within category, right? So let's move this over here into the next line, category, and then from which table? The temporary table that we just created, right? So this is what we are going to do. So if I just run this, what you will see is we have got this additional table, additional column that is created, rank within category. So within category you see that 1 2, and then smart home within category 1 2 3, and this is also ordered. So we are using rank. I'm not using dense rank or any other row number, so using the rank one. Okay, now what I'm going to do is I am going to get the final output, right? So let's try to get the final output. What was the final output? If you see the query, your output should include the product category, product name, and the total revenue generated. But the top two. So that filtering has to be done. To do that, what I will do is I will put this under a CTE. So we can start with ranked products, right? As so I will just put this under a CTE and then select product product category, comma item name, comma total revenue from this CTE that we started with, where the rank within the category. This one, what we want is it should be less than equal to 2. Why? Because we want top two only, right? So we want top two and then order by product category and where is this? Our product category and total revenue. So I will do product category, comma, total revenue. So pretty simple, straightforward, and then put it DESC. So now I will run this entire query in one go. So if I run this, you will see that books, top two, smart home, top two. Right. So what are the topics? What are the concepts that we discussed? What we discussed is how do we filter where group by. In fact, we did in the first question itself. But then we used first of all we used the dense, not dense rank, rank, basically window function. You should also explore dense rank and row number, how that is, how that differs. Anyway, and then we discussed with, which is CTE, and then how do we write queries using CTE. So that is about the third question. So that we have, not third, that is about fourth challenge that we have got. Okay. Now what we're going to do is let's move on to the next one, which is the fifth challenge, right? So let's see what is in fifth challenge. The fifth challenge is about analyzing sales associate performance with ranking functions, right? Primarily, I want you to work on the ranking functions. You are a data analyst on Amazon sales operations team in India. It's the end of the quarter, and the leadership needs a performance report on sales associated to determine bonus eligibility. So those things has to be done. What we need to do is our task is to write a single SQL query to rank associates within their department based on their sales figure. Then you must analyze the output to advise leadership on which ranking method to use. So basically, what should be our ranking methodology to use it to use to report such questions or to share such output, right? So primarily I want you to work on rank, dance rank, and row number. Let's see how it works. First I will create database, and then first I will create the table, insert records, and then I would be writing the query. Okay, so let's go there. What I will do is I just copy paste this one so that I can mention here. This is my challenge 5. So I will copy this format, paste it here. This is our challenge 5, right? This is our mission. Okay, the very first thing is that we need to create table, right? So let's create a table. This is our table. Here I will keep the schema as Amazon itself, as it was earlier, right? Amazon it was earlier. So let's run it. It would be blank. I'm not running. Let's quickly insert the records. So if I try to insert the records, I will just replace this. When I try to insert the records, and let's see what is into the table, right? So if I try to see select star, not into, from this, this is the, these are the records, right? Now if we go back to our problem statement, so what is the part one, the SQL query? Write a single SQL query that shows all the original data and add three new columns. We need to add these three new columns: rank performance, rank performance, the associate rank within their department using rank, dense rank performance, and row number performance. So basically I want you to write the query, I wanted you to write the query to populate these this table and then analyze that, right? Do the analysis over here. So that is what part 2 is all about. So I will, first of all, I will write down the query for rank, right? So if I just try to write down the query for rank, so select from which table, from associate, the table that we have got, right? Select from this. What are the columns? The columns are associate name, the second column is department, and then total sales, right? And then rank, I will bring this to the next line. Rank, the very first thing is that I'm going to use rank, and then after this we use over, because this is a row wise iteration. So partition by department, and then order by what, total sales, DESC, as rank performance, right? So let's just see what is coming as a result of this. I just have the rank, so you see that I have got rank. So for each department, right, for each of the department, electronics, 1224, and then home kitchen 1224, because this value 55 is same over here, right? So that is clubbed, and that is the reason why you see the output, right? What we cannot do is we should be including the dense rank as well, similar to this. So what I will do is I will simply copy paste this. Instead of rank, I will put the dense rank, right? So now if you just run this again, if you now just run this again, so what you see now is for electronics, what it has got is 1, 2, 2, 3. So basically it clubbed the same value. However, the next value is not skipped. So 1, 2, 2, and 3. So this is not skipped. Here it got skipped. So that is the difference between rank and, not this is rank performance, my bad. This is dense rank, right? So this is only about name, because that is the name that I use. So dense rank. So dense rank doesn't skip it, but it gives the same ranking if the value is same, right? Now the next one is row number, right? So row number, and the rest would be same. So row number, rest would be same. Here comma, and then here let's change it to row number, because column name shouldn't be same. Row number performance, right? So now let's try to run it and see what is the output. Row number is not, oh okay, here this should be B. Fine, let's see. So as you might be knowing that in row number, it gives the sequence wise numbering based on the logic where it needs to be done, like department. So for each department it is giving, sorry, for each department it is giving us the row number 1 2 3 4, and then for home and kitchen it is giving us 4 1 2 3 1 2 3 4, right? We can do the ordering as well, right? Order by department, ASC, total sales, DESC, right? Although we have already seen it, the results are same, right? So this is the difference between rank performance and dense rank performance, right? And row number performance as well. So what you see again, just to repeat things, rank assign equal rank to Rohan and Meera, because both have got 45, and hence rank is 2. Vikram then skips rank 3 and gets 4 over here. Dense rank again assigns equal rank. However, Vikram gets rank 3 without skipping. Dense rank doesn't skip. And row number forces a unique sequence in that department. So Mira gets 3 here, and then 4, even though both had the same sales, right? Same sales value. So now if I go to the second question, what was the second question? Not second question. What was this part 2? Explain the impact of ties, right? We need to explain, focus on Rohan and Mira, and then provide a business recommendation which one to use, right? So let's go back to our SSMS. So what we see is row number. Let's talk about row number. It is not ideal for bonus, right? Because fairness is not here. Rohan and Mira got same sales amount, sales value, but the row number performance, row number output is different, right? Even if you use rank or dense rank, it doesn't matter because we should be considering the tiebreaker. So it is same here. So in the case of top two rank and dense rank, the outputs are same. So we can use either of these, but again, you will have to write the query and see what is working, what is not. It's just here because the numbers are like this, but tomorrow numbers might be different, and that is the analysis, that is the intelligence that you will have to use. So this is about challenge 5. We will be now moving to the last challenge, which is challenge 6. So let's go here. Let's change it to 6 and go back to the question where I have posted challenge 6 and see what is there. This is the multi-challenge, right? Mirrors a real Amazon dataset technical assessment. It's a design to test your ability to answer increasingly complex, right? So these are the things that I gave. Database schema. This is the database schema. I would insert all of this. So these are the different questions now. 4 questions. What we need to do is we need to assume today's date is 26th of July, write a query to calculate the total number of units sold yesterday, weekly category performance, and so on and so forth. Right. So this is part A, right? So I will just copy this part A and we will go and paste it over here. Business as questions. As usual, what I would do is I would be creating the table and then inserting the records, right? So what I would do is create table customer purchases and insert the records over here. Again, as I said earlier, I am not going to use any, I'm not using any of the constraints. The reason being I want to keep things simple. But again, you should be using it if you are creating some system. So please keep that in mind. So I've inserted it. I would also create product catalog, right? So which is the another table. So I would just run this and let's now insert the record over here. So I will bring this to the next line and now insert the records. Now, if I go on and if I just see select star from Amazon dot, okay, this didn't run because if you see it over here, I didn't include the schema, right? So if you see the tables over here into the left side, so this is by default, this came into DBO schema, right? So by default, this is into DBO schema, which shouldn't be the case. I mean, I didn't use Amazon, that's why it is. So I will be using DBO. So keep this in mind. So if ever you skip it, it wouldn't be going into that schema. It would be going into by default DBO schema. So anyway, I will be using DBO schema only right now to just see these tables. So what I would do is I would be select star from DBO dot. I just want to see these two tables. What kind of data we have got? We have got this data, right? So if I just expand it, so we have got this data over here. The very first question. What was the first question? Let's copy this and let's put it over here. Write a query to calculate the total number of units sold yesterday, right? If you remember today's date, what I said is 26th of July 2025. That is what we have to do. So, in where clause, it should be yesterday, means it should be 25th of July, right? So, select star from customer purchases, right? I don't, I never recommend to include star, but I did just because I want to write star from customer purchases and I'm going to update things here. So units sold as units sold yesterday, right? From this and then where the where logic, date of purchase, timestamp, the date column, purchase timestamp, it should be equal to the previous date. I am assuming that the day is, sorry, this should be 25. 26 is today's date, right? So that is what I'm going to do, and I'm just going to close this and run it. Okay, so there is an error. Date is not a recognized built-in function name. Okay, fine. So this is it is not a built-in recognized built-in. So what I will do is I will use cast. So purchase timestamp as date. So I will just convert this to date using cast. So now if I execute it, what we saw is 2. So that is the output that we have got over here, right? We will now move on to the next one, the second query. What was the second query over here? The second query is, let's see there, weekly category performance. We need to write a query to report the total units sold for each product line over last 7 days, including today, right? So let's copy paste this one. So we will be writing this. This is the part of sixth challenge. There are 4 questions to that challenge, and hence we are working on it. So I will just put it here because we can then refer it. What I will be doing is, first of all, I'm going to create and see the weekly sales, right? So if you see the tables over here, I'm going to use both of these tables, right? Because we want to use product line from here and to create a weekly sales table. What we need to focus over here is how do we join these two tables. So if you see the common link, we connect tables, we apply joins based on the common link. So product SKU is the common link over here, right? So that is what we are going to do. So let's first create a temporary table where we store the weekly sales. So what I will do is select star from, please note star is just a placeholder right now. I will update that. This is CP, and then I am going to join product catalog. Let's call it PC on. As I said, this is going to be CP dot product SKU equal to PC dot product SKU, right? So that is what we have it over here. Now let's update this one, the select statement. So I want product line, and then I want sum of CP dot units sold, right? That I want as total units sold. So this is here from this table, and then what we are going to do is we are also going to apply the filter logic over the last 7 days and including today. So we are going to include today's date as well. And if you remember, the assumption was that we need to consider today's date as 26th of July. Obviously you can use today as well, but since in the data I don't have the dynamic updates right now, and hence I'm using 26th of July. So what I will do is where cast CP dot, earlier as you saw the date doesn't work, hence I'm using the cast. So purchase timestamps, I'll just copy this here, CP dot purchase timestamp as date. It should be between 202507 and then 20, and it should be 202507 and 26, just the last 7 days. That's what I want to ensure over here. And then there would be a group by as well, group by PC dot product line, because I have used that in the select statement, right? So if I just run it, what you see is we have got this over here. So this is done. We have got all of these over here, apparel, books, and electronics. So I think this is all what we want. Let's see what are the product catalog that we have got. So apparel, books, and electronics are here, and then we have got home goods. So there were no actually sales for home goods. That is the reason why we do not have any of the output. So what we can do is we should be showing 0 for apparel goods, not 0 for home goods, right? So what we'll do is we can do that as well. So I'm going to put this into temporary table. So let's put into weekly sales. Else we could have just simply done select star from weekly sales, but let's do this. We should be showing 0 for the ones where we haven't got any sales. So now select from, right? Select from what? We need to select the distinct values, select distinct product line from product catalog, right? Because we want to have that PC, and then left join the weekly sales, the one that we got on, let's call it ws on pc dot product line equal to ws dot product line. So we did this, but in the select statement what we will do is we will use callis function where we want to add 0 whenever there is no sales. So callis, right? And here ws dot total units sold comma 0 as total units sold, right? So if we just apply this, the output would be very much similar, but you see that home goods, for home goods we have got 0 because earlier, since there were no sales, let me run this entire stuff. So for time being I will just comment this one so that it doesn't go again back to that. But if I just run this, you see that earlier home goods were not there. This is the first query output, this query output, we don't have the home goods 0. But if you want to add 0 wholly set, right? So we, that's what we did over here. Okay, now let's go to the third problem statement. What is the third problem statement? We need to identify first daily purchase for each customer, find the purchase ID for the first purchase of the day, and the customer can make multiple distinct purchases on the same day. Okay, so I have copy pasted things over here, and then so that we can refer it. Now, the moment it says that we need to find the purchase ID of the first purchase of the day, and it also says that customer can make multiple distinct purchases. So it should give you a hint that in mind, how would you write is we might have to use some dense rank, or row number. The reason being, it is the logic of ranking because a lot of people doing multiple transactions, we pick the top ones, right? So that is what we are going to do. What we are going to do is we are going to utilize customer purchases table. So I will just copy paste it here, and then so that we can see the columns. First of all, we would be creating a table or a summary output, a table where we want to showcase the ranking function over there, and then we filter from that table. So select, okay, let's use this one only. In the select statement, what we will do is we have got shopper ID, purchase ID, right? And then purchase date. So I will just convert this entire timestamp to date. So purchase timestamp as date as purchase date. Okay. And then I'm going to use row number. The reason being I want to select the first one, and in that case, in this logic, the sequential ranking would make more sense. So hence I'm going to utilize row number. You can think of why rank, dense rank, whether it would work or not, but using row number it would work. So partition by shopper ID cast, I will just get this from here. Okay, order by. Let's pull to the next one. Purchase. Okay, so this is done. Here I need to say that. Here this needs a closer. Okay, this is done. Fine, perfect. Now, if I just run it, what you will see is you will see the output over here, right? You will see the output that iron has been shown over here. It has got 111. So what ideally what we will do is we will select all of these one from here, right? One from here. So we will put this into a temporary table. So at the end over here, before this into, we call it first purchase, right? And I just run it. Perfect. So if I just see now, select star from first purchase, right? If you say it now, what you will see is we have got the same output, right? Now I will write another small query to just filter it out. Let's use this one. What I want is, in fact, I want everything right now from this. So where rn equals to, okay, so I just run it. What you see is you have got the output. We wanted to have the for each customer find the purchase ID, for each customer find the purchase ID, first purchase of the day, first purchase of the day. So that is what we wanted to have. Okay, now the next question. Write a query to find the purchase ID of the second purchase of the day for each customer, but only for the days where that customer made two or more separate purchases. So basically, if there are two or more separate purchases, then only we need to calculate, we need to get the purchase ID. Interesting question, interesting analysis. So we will put things here and then do this. This. Okay, perfect. So what I will start doing is, we will first again do something similar, but what we will do is we will count daily purchases where there are two or more, right? Where there are two or more IDs. Select start from is missing, so I will just do this. Select start from first purchase. This ranking is already here. Now what I will do is I will get select shopper ID, shopper ID, comma purchase date, comma count of star as purchase count into, just putting it into a temporary table. Let's say purchase count. So basically, we want to have the purchase counts over here, right? Purchase counts from purchase first purchase, right? And then since we have done the counting, which is summarization, so we will be doing the group by. Once we are done with the group by, we want to have greater than equal to 2, so I will put that in having. So having count of stars should be greater than equal to 2. Please note, you should be very clear with the concept of having and where, when to use it, how to use it, quite commonly asked in interviews. I'll just run this over here, and then if I just see select star from which table, purchase counts table, right? So if I just run it, you will see that there is only one record. Why? Because earlier also, if you just see the first purchase, we saw that there is just, if I just run this, you will see that there is just one record where rn is 2. So it was expected, right? But now what we want to do is we want to get only the second purchase, right? Okay, so what we want to do is we want to select the purchase ID, shopper ID, purchase date whenever the count is 2, right? So let's write the query for that. So what I will do is select star from first purchase, right? So first purchase, I'm going to join this with purchase counts, right? Let's give it a name FP. Let's give it a name PC on FP dot shopper ID equals to PC dot shopper ID, and we will also match it with purchase date because we want to align the purchase date in these two tables. So let's use that as well, purchase date. And what are the columns we are looking for? We are looking for purchase ID. So let's use purchase ID. We are also looking for shopper ID, and the another one is purchase date, right? So if we do this from here all the way till here, and after this we are going to do fp.rn because we want to have only the second two or more separate purchases, right? So I do it. So you see that you get 005, 123, and 2025720424. And that is what we wanted to calculate actually, right? The for each customer, but only for the days where customer made two or more separate purchases. So here it is worth mentioning that we are applying the purchase date logic along with shopper ID, because we want to ensure using this that we want to ensure that same customer on the same day. So this is what we are trying to ensure. Even if I just turn this off, you would get the same output, right? Why? Because we may not have a lot data right now, but this is quite important to include because we want to ensure same date and same customers. If the data might be a bit different, a shopper made multiple purchases across multiple days, and if we just join on shopper ID, we will end up mixing rows from different days. You can try it out. You can insert records at the top in that sense, and write the query or run the query without this second logic over here. Just remove this, insert records where shopper did the transaction multiple purchases across multiple days and see the output. So that is why we need to include it. So that is all about the Amazon case study. I hope this was helpful. Let me know in the comments what else you are looking for. How is your preparations going? If these things were helpful or not. All these courses are available in the description. You can access it from there. You should follow the WhatsApp channel where I keep on posting weekly practice questions and other steps as well for your preparations. Thank you so much. Make sure that you subscribe and stay updated. Thanks.